it away.
Okay, so for this one, you're asked to find M, which is the ratio between the height of the tooth of the saw and its distance along the table from the center, or from this middle line. So basically, M is just the tangent of theta, because theta is, or tangent is the ratio between that height and that length. So all you have to do is plug in the angle you're trying to find into the tangent equation, and you get 0.753 is the ratio between the height and the length for 37 degrees, and it's 0.933 for 137 degrees. And the final part asks you to make a graph of the tangent function, basically. This part I didn't fully understand because, well, almost all the way until it gets to 90, it stays really close to the x-axis, and then it goes until it's almost vertical at almost 90 for the x value. And then it repeats, so the next point where it intersects with the x-axis is 180 and 0. So I was trying to figure out like what the x and y meant in this case, I guess.
Could you just like type that into Desmos and saw what it looked like, and we're trying to figure out
What it meant, yeah.
That's good. That's good. Anybody help Hayden with like what is the really it's the ratio between the height and the distance, right? But what's another way you could think of that tangent of an angle? What else is it in the unit circle?
The slope. The slope.
Yes, Dr. D. Everybody agree? That's just, it's the slope, right? So when that angle gets close to 90, what's happening to the slope?
A lot steeper.
It's getting pretty big, right? And in fact, how steep could it get?
Basically until it's undefined.
Yeah, right. It could get infinitely steep, right? Can't you draw a line from the origin to the unit circle that has essentially infinite steepness? Totally good. But what happens when you get to 90 degrees, Hayden?
When you get to 90 degrees.
Yeah, when you hit 90 degrees, what's the slope?
Yeah, it's undefined.
Exactly,
Like,
right?
if the tooth was all the way at the top,
Yeah.
like, this slope we don't have.
There is none, right? So there's something at 90 degrees. We haven't talked about these a whole lot, but there's a thing called the vertical asymptote there, meaning it never touches that line, right? If you drew a line at x equals 90, because it never exists, right? The slope never exists at 90. And what's also true at 270 degrees?
Same thing.
Yeah, it never exists. What happens once you get just a little bit to the left of 90? What's your slope now? What's that? It's negative, right? Now it's negative infinity, right? But you've gone to the other side. And does your graph on the bottom match that idea?
Yeah.
You bet, right? Like at 90.1 degrees, that's at like negative 4 million. Where are all the places that the slope is 0?
It's 0.
Exactly. Wherever you're there, right? 0, 180 degrees, 360 degrees, 720 degrees.
Yeah, so that's when like the height and the length are 0, so the slope's 0.
Everybody good? Nice.
Another way to think about those vertical asymptotes is what is the tangent function? It's tangent is, if we were to define tangent in terms of sine and cosine, what would we say?
Well, the ratio between the sine and the cosine.
Yeah,
Yeah.
The tangent of theta is sine theta over cosine theta, right? So what would tangent of 90 degrees be? It would be, if such a thing were to exist, right? It would be sine of 90 degrees, which is
Cosine of 0 degrees. Wait.
Yeah. So what would be? what would tan of 90 be if we tried to Suppose we were like naively trying to figure out what the tangent of 90 degrees is. So we were
Yeah.
told tangent of 90 equals sine of 90 over cosine of 90,
Mhm.
right? What's the sine of 90 degrees?
The sine of 90 degrees.
Good one.
Yeah.
And what is the cosine of 90 degrees?
0.
And what is 1 over 0? Undefined.
Oh, I see.
Yeah.
Okay.
Right, so basically the calculator at least knows this much. Calculators are pretty stupid compared to us, but calculator knows better than to try to assign a value to 1 over 0 because it's not defined. Or rather the programmers who program that.
I almost disagree with you because Desmos knows that, but the TI-84 does not know that
Okay.
because the way the TI-84 graphs things is it plots a bunch of points and it connects the lines.
Oh boy.
So if you graph the tangent on the TI-84, you don't get that graph. Do you know what graph you get? I mean, literally, the way it graphs things is it plots a bunch of points and then connects them.
Oh my god, you don't get like some sort of almost like
You get it connects these as well because it just does, right? So yeah, so if you type in the TI-84, you people think like, oh yeah, it's like a weird, but no, because it doesn't. Remember, like that calculator, as are all computers, really, pardon the phrase, really stupid, right? Mm-hmm. It can plug in a bunch of points and then it connects them, which sometimes is good, but in this case, terrible. Great job, Hayden.